go ahead and take a look at the definitions of relative minimum and relative maximum. A relative minimum is anywhere on a graph where we find a valley. Alright, so we're going down and we change to going back up. Anytime we transition from going down to back up, the point of transition is going to be a relative minima. Even if it's not the lowest thing in the entire graph, it's still relatively the lowest thing in that region that we're looking at. So here we would have two relative minima and two relative maxima, two peaks and two valleys. So if we take a look at finding the minimum of a function given by f of x equals 3x squared minus 4x minus 2, what we're going to want to do on here, it says use a graphing utility to approximate this. So let me go ahead and bring up my graphing utility and we'll work through this together. Alright, so we have our equation here, 3x squared minus 4x minus 2. Our window value should be from negative 4 to 5 in the x's and from negative 4 to 2 in the y's. If we go ahead and hit graph, this is what we'll find right here. And we want to find what is the y value at the very bottom. How far are we from the x-axis? How deep is our valley? So we're going to want to use our trace function here. And we're going to move it over, back and forth, and find the y value at the very bottom. Negative 3.33 looks like the lowest we can go. Now we're pretty far zoomed out here, so we might be able to get closer and see if we can do a better job. So let's go ahead and use our box zoom, and we're going to want to start just to the above left of our minimum, hit enter, we'll go down, create a box around it, hit enter, and it'll redraw it for us. Now we're zoomed in quite a bit closer when we hit trace here and find the minimum point. Looks like that is, and so now we're getting a lot closer, negative 3.33333. I'm willing to bet that if we zoomed in even more, we would get negative 3.33 repeating forever. Alright, so our solution here would be x equals 0.66 or 0.67 since we're going to round, y equals negative 3.33 for our relative minimum. So coming back over to our problem here, go ahead and try exercise 57. Use a graphing utility to find the to two decimal places any minimum or maximum values. Alright, so here's our graph, y equals x minus 4, x plus 2. We go ahead and graph this, we'll get something like this, and so we're going to want to zoom in around our relative minimum and then use the trace function to see what our minimum happens to be. So there's zoomed in, let's hit trace, and we'll go sideways, and it doesn't look like we can get any lower than 9. So x equals 1, y equals negative 9 would be our solution.